So welcome everyone in the problem solving and doubt clearing session number 7. Number 7 for the course title M891 Production Technology Theory and Practice. So we first start with the assignment for the week 6. Okay. This is the question. When the cylinder workpiece is turned between the center, the rotation is imparted the workpiece by. So here the faceplate is actually different concept. And to collect again in collect we don't have a centers. Okay. In faceplate we don't need a centers. In collect also we don't need a centers. What they are asking is turn between the centers. Okay. In both of the cases these centers are not there. In dog and clapet centers are there. It's probably correct answer. And three judge also there is no any centers. Okay. The centers means like this. On the both side we have the centers. You know, and between this there is a your workpiece is placed. Okay, so this kind of arrangement is only possible, or it is there only dog and dog plate. Okay, so this answer will be your correct answer because this arrangement. Any of these cases, this kind of arrangement is not there. There is only one center we have in all of these cases, but only dog and dog plate we have two centers, and there is again dog plate to connect it, and it is now having some. Here the dog plate is there again, and due to that dog plate we can mount here something. There is a pin again, and there is a dog plate arrangement, and due to the pin it is one. So it is held between these two centers. Okay, so this answer is correct. Okay. The second question is operations performed on the inside diameter of a hole is or are. So turning is not performed inside the diameter. Okay, it is performed outside the diameter. Okay, and boring is yes, boring is performed, and draining is generally used to create a hole. Okay, you have to create a hole. Other than to perform operation. Okay, it is generally used to create a hole, and reaming is also used to on a inside diameter. Okay, broaching is also used inside diameter, and shaping is for planing. Shaping is a connection with diameter of shaping. Okay, shaping is not for shaping because of diameters. So what do you have here is these options are watching, reaming, and boring. Okay, so this 2, 4, and 5. Okay, so 2, 4, and 5 will be is your correct answer. Okay, with this. Okay, D is your correct answer. Point angle in a drill is the angle between the lips that you know. Okay, it's everybody knows it's easy. It's between the lips. Okay, point angle is between the lips. The drill axis and the lip, and drill axis and the chisel edge, flying face and drill and the line normal to drill axis. The point angle is between lips. Okay, the sieve number of 46 average grain size has a nominal diameter of about microns. So here they are asking for DG and we know the formula. Okay. They are asking for the DG and we know the formula is equal to 0.6 by your sieve number. So your sieve number is given here, which is the 46. So what you have DJ is equal to 0.6 divided by sieve number is 46 is equal to 0.6 divided by 46, that will come out some about 0.0130 inch. Okay, it is come in inches. So this formula is for inches. So we need to remember while solving this that this formula is for inches. Okay, so this will be in inches. Okay, we need to convert it into millimeters. So what we can do, we can divide this by 39.37. Okay, so we'll get answer something like 331 into 10 raised to minus 6 meter. Okay, so when we got this meter, and what is on that would be means it is in micron. So what would be your answer? 330. Okay, because plus 331. This is the case. So 330 will be your answer. So this is how you can solve this problem. Okay. For a grinding brass, the grade of the grinding wheel to be selected is it, it is mentioned in the slides that for brass you have to go with slightly more hard tools. Okay. Like more hard grinding wheel, which is, can we start with Q. Yes, for Q we need to go with this. Yes, for brass we need to go with this because it's hard material. That's all. High strength material, hard material. So we need to go with this Q because your hard material starts with Q series. It is, you know that fact. Okay. For grinding the low tensile strength material, average material that should be used is low tensile strength means is a high hard material. Low tensile strength means brittle and have quite high hardness. So when it has actually high hardness, so which select tool will be used or which abrasive will be used? Silicon carbide. Aluminum oxide is for tungsten, like like normal high strength materials, but here it is low tensile strength. It is aluminum is for high tensile strength, not for low. As it is low, means it must be hard material. Okay, here mentioning that low tensile strength means it's a hard and brittle. Okay, and for case of this hard and brittle conditions, what we can use is silicon carbide only. So silicon carbide only is correct answer. Okay, this aluminum oxide used for high strength materials. Human nitrides are expensive materials. Okay, they are like they are used for very high end applications. So it is another produce. For better surface finish, the workpiece surface, the grinding wheel structure that should be used is, you know that it is start from 0 to 60, and 0 is completely dense structure. You know this fact is dense structure, and here it is kind of open structure. Okay, so you know these facts. So in case of this, like yeah, so in case of this like structures, what we will use, like this is it is a dense structure and it is open structure, but you want a better surface finish. So for better surface finish, it should have more number of chip carrying capacity. So for chip carrying capacity, what we will do, we can go for open structure. Okay, for open structure. So what is the maximum? This is the maximum open. For maximum surface or better surface finish, you need to go with maximum number structure. That is which is maximally open. So you will have a better chip accommodation. Okay, better chip accommodation will be there, and with that proper chip accommodation, the surface finish will be high. Okay, surface finish will be high due to what? Due to the chip gets accumulated in the voids that present when we are using the open structure. So with open structure, you can go with good surface finish. Okay, so 16 will be your answer. As it is, it will be a open structure. Okay, due to open structure. Okay. So next question: the aluminum alloy used to be ground in an external cylinder grinding separation to obtain a good surface finish. The most appropriate grinding wheel for this purpose is, again we are using aluminium alloy, so we can go with aluminium oxide, which is hard material, which is high strength material. Okay, aluminium oxide. Okay, you can go with this aluminium oxide. So it will be A. And again, what is the secondary condition? The grinding operation to be obtain a good surface finish. So for good surface finish, we need open structure. That means it should be number should be more, so like 12, and this 7 and this 5 structure will be directly cancelled. Okay, you know how to solve this question, right? This 5 and 7, this concept are already cancelled. This A is there, but the C part is already cancelled, so C can't be used because it is we can't use for silicon carbide for this concept. You can go with aluminum oxide only. So this 5 is also cancelled. So what we left is only this answer. We have you have aluminum oxide, you have for better surface finish, you have 120 mesh size. Okay, if you have surface finish good, 12 again it's hard. So you will get, considering everything what you know, it is stellite bond, okay, and it is a kind of soft medium material and it's stellite bond. So considering everything what you have, a better surface finish, okay, for aluminum alloy. So this will be your answer. You need to how to eliminate the other parameters that you need to understand, and this is a perfect tool for us because we have everything like A, we have 120, that is fine mesh, we have like medium fine, not fine mesh. H, we have that is hard, some kind of medium open structure and stellite bond, okay. So it will be good for better surface finish, okay, for aluminum. The better surface finish, I told you in my previous assignments also, there is a different type. You need to go with conditions that you have. So better surface finish you will have plus what you have. You have aluminum alloy. So both you will have, that is you will have aluminum alloy and uh, aluminum alloy plus your good surface finish. So these two conditions are satisfied here. So what will we go with? A. So we'll go with this D. This A means aluminum oxide, I'm told, but option here is D. Okay, so we'll go with D answer. Again, the grinding wheel of 200 millimeter diameter, rotating at 200 rpm, and zero point 0.6 active bearings per millimeter square is being used to grind the mild steel flat. If the width of the cut is 5 millimeter, the number of chips produced per second is. So we know we have direct formula for this kind of problem. So we know the direct formula, that is number of chips. They are actually asking the number of chips only. So we know the direct formula. So number of chips, which here we need to calculate. The number of chips is equal to pi into d n p c divided by 60, because your n is here in minute. Okay, your n is here in minute. So for to get into seconds, we need to multiply it by or divide it by, sorry, 60. Okay, as it is in minute. So convert it into second. So what we will do? We are dividing here. Seconds. So what we are doing here? You are dividing here by this 60 factor. Okay. So what is your answer here? What you will put? I have to put pi. You will put here. You put this d. That is your d. That is your. Okay. Where is your? Here. Okay. Here. 20 meter diameter. 200. 200 millimeter diameter into your n, which is 2000. Okay, this is your mention your 2000 rpm, and this is your active grain concentration. So this, so B you have, this is your width of cut 5 millimeter, and this is zero point 0.6, which is your grain concentration divided by 60. So your answer will come in this range. Okay, as is 62832. So this will be your answer for number of chips that can be produced during the grinding process. Okay, for a surface grinding process with 6 millimeter feed velocity, 5 millimeter width of cut, and 4.5 millimeter depth of cut, the material removal rate in millimeter cube second will be. So it's a direct formula you have. So what let me just go with what given you have. So write down just, okay, we'll just go with what given we have. For a surface with a feed velocity is given. So Vf is equal to 6 meter. See, 86 meter when everything else is in millimeters. So you have to check every time that unit conversion is again important. So this is in meters, so you have to convert it into millimeters. Okay, in further operations. Okay, so and your width, that is your B, is equal to 5 millimeter. Your cut and 0 point depth of cut, that is your D, is 0.05 millimeters. Okay, so the material removal rate you have to ask. So you know the formula for material removal rate. So material removal rate is equal to, that is your, just get MRR is equal to B VF T divided by 60. Okay. Why you are using 60 here? Again, you know this is in millimeters and we want in seconds. Okay. So unit conversion is most important here. Okay. Previous example also I told you why you are using 60 because this is in minutes, this is in seconds. So unit they want in seconds, we have in minutes. And also in meters. So 10 raised to minus 3 we have to multiply 10 raised to 3. Okay. Because we have to convert meters to millimeters. Okay, so to the last. So P, you have what is the value of P? 5 millimeters. Okay, into BF we have at is 6, that is here. When raised to 3 we have D, we have 0.05 all in the millimeters, and to compensate the meter or meter and also minute, this minute to compensate, so we are 60, you are doing it by 60. So what will be your answer? So we have to calculate everything, so we know what to divide by 60 because this is in minute, so converting here minute to seconds, so we are using this 60. Okay, so it will be 725 millimeter cube per second. Okay, because we change everything. Now we change everything. We come units are changed to millimeters. So and the unit is changed to meters per second. Okay, so you can go with millimeter per second is your correct answer. You have to be with units. Okay, this changes to 3 and this factor we additionally added. Why? Because mm and minute we have to convert it into millimeter per second. Okay, this is the part that we need to do. Okay, so you will get answer. Okay, so this is the last question of the assignment. So right now we go with the problem statement, like problem practice sets, and try to solve the problem practice sets. Okay, so this is the first question for you. What is not true in case of phase 2 of grinding wheel pair? You can take like minute if you are going to answer. So we'll take a minute and start the answer. You can't go directly next, going. So what is true? This is not true actually. In case of phase 2 of a grinding wheel wear, this is the question that you are asking here. So what is true in case of phase 2? So you know where is the phase 2? Phase 2 is where that is phase 1 is gone, and so 1 minute is not over, but just you can go. Like phase 1 starts from here, and there is a constant phase, and there is again this like a phase. So this is like this constant phase we can go say, and this kind of constant phase we have. So between these we have phase 2. Okay, this is the phase 2 actually. Okay, this is the phase 2. So what we have in a phase 2 that we are asking here. Okay, 1 minute is over. I think so we go with rate of the wheel is constant is correct. Okay, rate of the wheel is constant statement is correct. We go with green color here. This statement is correct. The rate of the wheel is constant. Continuous self-rafting action is there. Okay, this is again correct because of the force is increasing. You can see in this section there is a dislodging of the particles are taking place, and due to which self-rafting, that is new grain will be come into the picture, and the old grain will be gone out dislodged, and the new curve will come and it will start grinding. Okay, so continuous self-rafting action will be taking place. Okay, that's correct. And the practically no wheel dulling which obviate the need of dressing. Okay, practically because of shelf sharpening there is no need for dressing. Okay, dressing is if there is a problem of grazing or loading. Okay, if there is no grazing, there is no loading, then there is no need for dressing. So here what is happening, the it is actually dislodging automatically because of the force and the less bond strength we have, this automatically dislodging the process is generated mechanical dislodging, and what is happening, it is getting shape transfer. So practical no need for dwelling which is obviate and analysis is again correct shape. Okay, last for very short duration. Okay, it is about mention last for very short duration. So here I am showing that it is actually the longest part. So it is longest part actually. The issue is very long. So last for very short duration is wrong. Clearly it is wrong. So because it is everything is going perfectly. So this case is wrong, and this will be your answer because what they are asking here, which is not the true. Which is not the true. So this last part very short is not the true. Okay, so this will be your answer. This last part is short, it will be your answer. Okay. So which of the following are grinding wheel wear phenomena? So you know that what of the part that you have. We go through the slides. So when we have wait for 1 minute and then show the answer to you. So you can go continue talking. So if you know the part that which of the following gardening will be in phenomena, so you know the actual concept that attributes where we will have. Yes, what is arthritis where that is the flat getting more flat and that is arthritis where that is very normal. Fracture where yes we have fracture where also bone first fracture yes we do have bone first fracture also. So basically we have all of the above fracture. So here the correct answer will be all of the above. The average fracture you know like you know like it is getting flattened. You know it's getting flat. It is getting flat. And again fraction where means it is fractured between some this axis it is get fractured. And bone force means it is told that bone force means like this is the bond between these two grains and the bond here. That bond will be break. This bond will be break and it will be dislodged. Okay, this is going to be dislodged. This is called post blood. Okay, so everything is actually happening inside the grinding wheel. So our answer will be all of the above. So all are correct. So all of the above is the correct answer. Okay, so this all of the above will be the correct answer. When a grain is stronger than the bond force, the grain pulled out of the bond force when sufficient force is applied at the grain, which is called as. So what it is called as, I already mentioned to you that what it is called as. Okay. I told you answer already, so what it is called as. If you can correct the answer and move on or can wait. If everybody want to read again, you can read again and answer it. It's not a problem. Okay. When grain is stronger than the bond force, the grain pulled out of the bond force when sufficient force is applied at the grain, which is called as. So attritions where I told already attritions where is get the what we call attritions where the bottoms like are getting flat. Okay, the connectors are getting flat and flat and flat. And fracture also we know there is some kind of fracture here and this part will be ruptured. And the bond force fracture, this is the correct answer for this. Okay. So the what is bond force fracture? I also told you that know exactly what it is means. Sufficient force is applied again is pulled out. So this is what actually they are implant here and what I already told you that this kind of bond is present over here. This kind of bond is present over here, like you know. And here what actually happened is this bond are breaks and this bond as these bonds are break, what happened? This tool entire grain will get discharged. So entire grain will be going out and the new phase, your new grains will be coming in this contact. Okay, these new grains will come into your contact now. So these new grains will come into your contact. So which is correct. These new grains will be come into your contact and it is called as for post fracture. Okay, and this tool will get out. Okay, why? Because this bond will also weak, so it will again get tear out, and this your next fresh abrasive particles will be showcased or kept in the actual grinding process. So this is actually the actual definition of bond post fracture. Okay, this is the correct answer. This is the correct answer. This is bond post fracture. Okay. What from the following causes the higher temperature grinding process? So you must know the grinding process now. Okay, the concept is about grinding process, so you must recall everything about the grinding process now. You can solve some time by yourself, then I will go show you the answer. So you know the formula simply, the formula on which it is actually depend. Okay, so what is the formula for that? Your grinding temperature here we are asking for. What is the formula for the grinding? So let's start right now. Time is over for you. So theta. So theta is proportional to what we are writing here. Your P0 is there. Your D. I'm not writing either proportional here. Okay, you can check. So just it is something raised to, but it is what we are having here in this denominator or numerator. That is the relative question or equation question. That what you are asking here. Just to check don't keep repeating writing there. Okay. So it will be D. It will be C, and again you are adding. Okay. This is the adding process. Adding process and VF. Okay. Okay. So so it is to write triply here. Reduce the table field velocity. If you reduce the table field velocity, what will happen? The temperature will obviously increase because your denominator getting loose in the document. So it will increase. Okay, so this will be the cause of temperature is correct. Reducing the diameter of wheel. Okay, this is not the cause. Reducing the depth of cut. Depth of cut is here. Okay, so again not a cause. Reducing the rotation of speed, not a cause. So you can write it directly write the formula, or you can just remember the formula. You if you know the everything, so it is very simple for you to get what actually on what it is depend and what it is doesn't depend. Okay, so here you can directly get the answer that on which factor it is depending. So by this you can go directly. Means you can answer this question, this kind of question directly because it's very simple now. Okay, you write the formula and it's very simple now. You can get the answer very fast. Okay, very fast. So then I told you reducing the table field will be correct answer. Okay, all of these are wrong answers. Okay, as shown here. Okay, so this is the correct answer. So right now we go to question 5. So you can take time to solve. So just will be made for half a minute. Like okay, so you will also get a time to solve. If you want to think on it, you can get time to think and guess the correct answer. And after that, I will start elaborating what is the correct answer. Okay, this is what we can right now mistake we can use. Okay, so what from the following helps to keep temperature in grinding process lower? Exactly, I told you previously that you just write a formula and you can get the answer very effectively. Okay, so again, it is theta is same. So theta is proportional to what? Here we are asking. You are like you know that I just write the formula. It is the same by writing here again, and you can it will be easy for you to get what will be your answer. Okay, so again, this is same. So what we are asking, reducing the grinding ratio. What question is actually what from following helps to keep the temperature grinding process lower? Okay, the question is for lower right now. Okay, for lower it is asking for. So reducing the grinding temperature, what will happen is what will reduce it? Reducing the grinding ratio. Yes, it will reducing the grinding ratio because in the denominator it will reduce the temperature. Okay, reducing the grain size concentration again it will reduce the temperature. Yes, increasing the specific energy required to remove 1 millimeter of handkerchief thickness. So what is this? This is actually UC. So if you increase the UC, your temperature will increase or decrease. Obviously it will increase because it is in numerator. If you increase, the temperature will increase. But right now what we want? We want lower. So both. So we have the option for both A and B. So this will be the correct option. That both A and B will be the correct option. Okay. This kind of question might be asked. Okay? So the both of these are correct and this is actually wrong. So both A and B correct is your correct answer. Okay. So here this will be your correct answer. That both A and B are correct options. Okay. So the fifth question. What is true about the honing process? Right now we are going to honing process now, so we know what is hone. Okay. Right now we are going up to the honing processes. You can have 1 minute if you want. You can answer it and you can go. I will start elaborating afterwards. A simple process, okay? What we are asking, okay, we get the answer. So what is true about honing process? The finishing internal hole, okay, we are using the whole honing process to finish the internal hole, okay. It's the correct concept, okay. Finishing the hole is again correct option. Performed at low speed, yes. It is mentioned in the slide clearly, okay. So because we can't hide the temperature, okay, because of the temperature. Temperature restrictions we can reach right there. There are the temperature restrictions or temperature rights. Okay, so will be there because of the high speed. Okay, if what about the temperature rise? If for high speed, okay, temperature rise will be for high speed. Okay, so it is low. Perform at low speed is the correct option. Okay, both are the finishing the is correct. Perform at low speed is correct. No repetition of brain mass is also correct because it is done. Like we know that what kind of marks it is possible. Okay? This kind of marks you will got, which is again no repetition of brain mass. Okay. So these are also all of the are correct. So your answer will be all of the okay. In the honing process. All of the are correct. So all of the is your correct answer. Okay, because all finishing interval all are correct. Okay, so all of the above is your correct answer. Okay, go with this question. The surface generated in the honing process is used for. Okay, right now I told you the surface that is without no repetition it is generated like this. Told you without repetitive marks. So like this it is generated. Okay, this is what it is generated because you are moving it is that like that process. Okay, in that direction, that way we are actually rotating it or rotating our horn. So it means this kind of non-repeatable grain marks we will get, and this kind of structure we will get. And what is use of this kind of structure in the question here? Okay, this kind of point you will get a set of surface you will generated. Okay, so what is the use of this? Okay, that should be your question. Okay, so this question. So if you can take 1 minute to answer this question. Okay. Okay, I think 1 minute is you can get the answer. Okay. Surface generated in a horning process is useful for high speed operation. Is there any necessity of high speed operation by using this? High efficiency operation, is it contributing to high efficiency operation or it is to retain the lubricant or none of the above? Nothing. So high speed operations is not a cause here. High efficiency, this doesn't go for high efficiency surface structure. There is no any use of efficiency or high speed operations. Okay, but it has a growth. Okay, there is a growth. Okay? There is a marks. There is a small cavity. Okay, very small thing. Okay, small grooves. So where your abrasive, the abrasive marks. Okay, small abrasive, small grooves like okay, you will have grooves. What it will do? It will retain the lubricants. Okay, so it will have very small grooves which will be used to retain the lubricants. So this will retain your lubricants and retain actually this lubricant. Okay, lubricants it can be used there This means more small grooves and is to use less for lubrication. Okay, so this is the correct answer. So to retain the lubricant. Okay, this lubricant will be retained here. This close. Okay, in this small part because due to pressure and force it will be extracted and it will be retained in this kind of grooves. This kind of space it will be retained. So to retain this, when we apply the force or the force is increased, the lubricant may go spill out. So not to stop the spilling out, to retain the lubricant, you can these grooves or these small grooves will be here to accommodate it. Okay. So your correct answer will be retain the lubricant. Okay. So this to retain the lubricant will be the correct answer. Okay. In the grooves. Okay. This is the question for you. What is true in case of lapping process? Okay. We will take a 1 minute to answer this question. So I think to go to the answer. Okay. So what is true in case of lapping process? So laps are made of softer material than workpiece material. Okay, this is already is mentioned slides. Okay, simple. So yeah, the laps are made with softer material. Okay, that's correct. So straight and narrow grooves are cut at 90 degree to lap surface and charged with sprinkler abrasive powder and suitable fluid. This is incorrect because so it is soft material and we are having that these grooves is sprinkled by abrasive. Okay, so this straight good that 90 degree perpendicular we have and it is done sprinkled by some here we are abrasive sprinkling. Okay, and these abrasives are stick here. Here they are abrasive there. What pieces are against the lap and moved in path of 8 because to get no repetition, no repetition of tool marks, okay, or abrasive marks. So no for no repetition of abrasive marks. So no repetition of abrasive marks. We are using in path of 8. Okay. So for no repetition. Okay. So no repetition. We are using this part of 8. This is again correct. Okay. If we get mark like in this texture surface with no repetition. Here we got no repetition. Yeah, like this. This is also like no repetition. No repetition marks will be there. And so what will be the answer here? All of the above. As no, so we are using no repetition. So all of the above is labs above subcommittee is the correct answer. The straight narrow grooves are cut is again correct and no repetition. So all of these are correct. So all of the above will be the answer. Okay, for this question. Well, all are correct. So all of the above will be the question, the answer for this question. Okay, so the part are confined into cages that impart rotary and gyratory motion at the same time to workpiece for covering the entire surface. This process is called as. Okay, we are putting in cages. Some cages we will put it and it will be rotated every direction okay, like this or even like this. Okay, gyratory, rotary, everything is rotated to get cover entire surface. Okay, so we get entire surface coverage. Okay, it rotated in every direction to get entire surface coverage. So what this process called as? Yes, we know this process is called as machine lapping. So in case of hand lapping, you know Like hand lapping is simple. We are using by hand. Okay, so simply by hand in a figure of 8 you can do it. And a gravitatory motion and it is sealed in bag. It is not done in hole because and hole and shaft it is not done because what we are doing, we are doing a gyratory motion also. Okay, in this only rotary motion it can be done. It can be done with that only. Okay, but right now what we are doing, we are doing both motions. So only machine lapping will be the correct answer. Okay, so we have most appropriate answer machine lapping. And this is the correct answer. Okay, so you can because whole and lapping will be you can go with the rotary motions also. Okay? There is no need for that much like gyratory. Okay, this motion is not written there. And okay, and only in machine cases only you can have this kind of operation is called as machine learning. Okay, only machine learning will be the correct answer. Okay, this will be the correct answer. The factors that can be varied during machining operation to change the cost is are. So what factors you can change during the machining operation to change the cost, which is again important cost of machine. Okay, the factors that can be varied during the machining operation to change the cost is are tool and tool work material. Yes, it is a correct answer. Tool and tool work module is the correct answer. The tool geometry. Yes, tool geometry will be the correct answer. The cutting fluid will be correct answer. So what is that? Actually, the answer. All of the above will be the correct answer. Okay. So the factors that are varied during the machining operation to change the cost. So tool and work material can change the cost. Okay, because the tool cost is there, workpiece cost is there. Tool geometry, your forces, power, and everything will be came here. Okay, the forces will be came here, and cutting tool will be for temperature. Okay, so you can go with temperatures and strain hardening and all concepts you will have. So it will directly and also involve is individual cost. Okay, it's individual cost will be also there. Okay, it's individual cost will also there. Okay, so these things will be take while operation cost, total cost. Okay, and by changing this, you can change the cost. Okay, so all of the will be correct answer. Okay, this all of the above is your correct answer here also. So an optimum cutting speed always exists for each application, which would mean a compromise between what it will mean. It will mean the compromise between a labor cost and a coolant, tool material and workpiece material, production rate and tool cost. None of the above. None of the above is not option. An optimum cutting speed always exists between the what is the difference between like what is the relation between cutting speed and labor cost and coolant? There is no relation. And tool material and workpiece material with cutting speed, yeah, there is relation. But we don't to compromise on anything here because you can go with different. There is a many varieties are there. So we don't to compromise anything for cost. We don't to compromise anything here from material and workpiece. There is no compromise. What we are compromising here is production rate and tool cost. These are the things because production rate and tool cost is not a question. Just tool material and workpiece material. It can be anything. You can go with things. Okay, there is a many factors involved here. So we can write this correct. Okay, tool material workpiece is correct answer here. It's called cutting speed and of compromise between both. That is, there are different things are available, but for specifically for compromising, the production rate and tool cost is the most appropriate answer here. Okay, production rate and tool cost because production rate and the more the production rate you have, your velocity will be high. No, and as you increase the velocity, what will happen? Your tool life will go. Tool life will go, and tool life will go means your tool cost will increase. So that is the compromising factor here because we are increasing the production. but you are getting more tool cost. So it is not good because you are paying for more tool cost. You are getting high production, but you are also paying for more tool cost. So you are actually increasing your cost. So there must be an optimal value for everything. So for which optimal value will exist. For labor cost, it should not exist. For tool material, work material, there is no optimum thing which can be exist. Okay, so most appropriate answer here will be production rate and tool cost only. Okay, because only you are the optimality will increase. Okay, exist most appropriately here. Okay, which is mentioned in the slides also. So this will be more correct answer. Okay, the production rate and tool cost will be the correct answer. Okay, so this is the 11th question you can answer. It's a simple question. Okay, you can answer very easily. It's very simple question. It's just question from assignment. Okay, so directly from slides. It's directly from slides. So there is no really problem for you if you answer. Okay. Okay, so this is direct question, direct like question. Which of the following are economical aspect of machining? You know, minimum production cost criteria. Yes, it is there is for minimum production cost. Okay, minimum production cost criteria is there. Okay, so for minimum cost, you have you can have a criteria for maximum. I told you, okay, because this is again the appropriate answer. Okay, so you can see why this is appropriate answer is okay because these are two actually criteria are there. Okay, so minimum production cost criteria and minimum production rate criteria. Okay, they are always they are actually there and this need to be compromised. Okay, this thing that is true. Here tool material and workplace you don't need compromise. Okay, here there is no compromise. Okay, here is no any compromise required for this. Okay, but here there is a compromise. Okay, there here the compromise is required. So this will be the production answer. Okay, so here you can this is production rate. Okay, production rate and cost. Okay, then this why we can consider here because tool cost means again your cost is only this tool cost this is your cost only. Okay, so that things already exist. Okay, so we are actually made for this. So this would be the that would be the correct answer there. And here what we have is it's actually mentioned in the slide, so it is already present. And the maximum profit rate. Okay, so there will be maximum production cost or minimum production cost, specifically maximum production rate and maximum profit. So minimum production cost, maximum production rate, and maximum profit. So this can be your economics, can be used for ton. Okay, so all of the above is your correct answer. Okay, all of these above is your correct answer for this. Okay, so the final choice of the optimal value of cutting speed will have to satisfy which restrictions? Restriction oblique restrictions means one or more. Okay. Okay, so the final choice of the optimum value of cutting speed will have to satisfy which restrictions? Maximum power restriction? Yes, because the machines are limited, machines are with limited power. Okay, maximum surface finish restriction? Yes, this they are allowed. Force and vibration restriction, yes, it is there always. Speed restrictions, yes. Because with length, it is like there is a restriction that we can't go arbitrarily at every angle because there is a gearing ratio and everything will be concerned. So it is presets. So as there are presets, there is a restrictions. Okay. Because of this presets, there is a restriction. There is a mechanism for pulley and everything. There is belt and pulley mechanism will be there. So for there will be restrictions for speed, force and vibrations will be restrictions because it will deflect the accuracy. What will happen? Your accuracy will go problematic. Your accuracy will diminish. That means decrease. Your accuracy will decrease simply. And the surface finish restriction again means surface finish will how it will be surface finish will changing here. There will be restrictions because depending upon the like what we have application, there is a restriction for it. Okay, so maximum power we have machine limited. Surface finish we have application. Force and restrictions we have accuracy problem. And speed restriction because of preset restriction. So all of the above is correct answer. Okay, so all of the above will be correct answer. You can mention that. All of the above anyhow is a restricted activity. How the way it can be restricted. So it restricting in any other sort of way. So this will be correct answer. All of them will be correct answer. This is 13th question. Surface finish during cutting doesn't depend upon. So what you are asking here, the surface finish doesn't depend upon what? Doesn't. This is important word, okay? Tool work material, tool geometry, tool length, power requirement. The straightforward answer. Surface finish and power requirement have the own value. No relation between them. So simply your correct answer will be power requirement. There is no relation between. This everything will anyhow cause your surface finish. Okay, affect your surface finish some by some way. Okay, so what will not affect your surface finishes? Power requirement. Okay, so this power requirement. This is coolant and power requirement will not. So power requirement is the correct answer. Surface finish during cutting speed depends upon what are the factors when it's the cut that it will depend on. Does it depend upon labor cost? Simply, it will not. Machining time, not. Cutting conditions, yes. Tool cost, not. Simply, labor cost will not know in relation to surface finish. Machining time no have in relation to the surface finish. Yes, tool cost no have in relation to the surface finish. So what we have, this will have a effect on surface finish. Cutting conditions. So this will be correct answer. Cutting conditions will be a correct answer. Okay. So 15th question. For from point of view of surface finish are predominant phenomena. R means established R. This established R predominant phenomena. Not be a question mark. But is asking this question also very difficult. So if you know, you can go to the slides. The correct answer is feed marks. Okay, this is mentioned. The slides, the feed marks are actually the important phenomena. So surface finish point of view. Feed marks, okay? Because everything we are calculating by feeds only. You can see in the after that slides will show that even our turning what it depends on what again f divided by some cos again f square by 8r. So everything is depend upon r only. This f r is depend upon but f is again predominant. So feed marks is predominant. The feed the way it is the way like it is feed is given the way it is moves. Okay, the way this is actually happening it's the feed mark. So it depend upon feed mark. So coolant and power requirement it is not useful here. So only the correct option is feed marks. Okay, the feed mark only your correct answer it can be correct. Next question. In machining operation, what are the sources of heat generation? Okay, this is very simple question. So for BTech, it is very simple question. The shear zone. Okay, so sources you are just asking. So shear zone, yeah, it's correct. No, shear zone is option where the actual plastic deformation is happening. Okay, the plastic deformation is happening here actually. And tool chip interfacement is rubbing action is taking place here. Okay, rubbing will take place here. And work coordination again is like rubbing only because it is working with machine surface. So again, it's kind of rubbing. So due to heat will be generated. Okay. So in all the cases, there will be generation of heat. So as the heat is generated in all the cases, all will be the source of heat. Yes, heat is generated in all the cases. So all are the source of heat. So shear zone, chip to interface are working. So all of the above are correct. So these will be option. All of the correct options. Okay. So all of the above will be your correct option here. Okay. So okay. In chip machining operation, which source generate more heat? So we know like up to 80% to 85% heat is generated only in shear zone. You know this answer because this is actually deformation. Deformation is actually happening here. The rest of the case is just rubbing. So actual deformation is happening here. So it will have more temperature. Okay. So your correct answer here will be shear zone. Okay. This shear zone. Your correct answer. Okay. In machining operation, major heat is carried away by. Okay. So there is actually a graph shown on that. Okay, like this and this like this like graph is shown there. You go this this like and here they show most it is taken by chip. This everything is taken by chip. This by tool material again this by work material. Work material take the list and chip will take the maximum. Okay, so you know these facts. Chip will take the maximum and as a chip will take the maximum amount of heat so it is taken it away and it is cooling the our machining bill. So maximum effort is much cheaper. So 19th question, the best possible finish that can be obtained by given operation is called as. So forced roughness, natural roughness, ideal roughness, none of the above. So best possible finish that can be obtained by a given operation is called as. Best possible finish means surface finish. Surface finish is high. What is actually means? Surface this is low. Okay, so what like both are same. So means what is called as forced roughness. If you go to the slides, you know it is not called forced roughness. It is called as natural roughness. Natural roughness is different. You know, you go to the slides. It is ideal roughness, yeah, it's straight answer. Because it is maximum that can be possible. Okay. And none of the above is wrong option here. So maximum that can be possible is called as ideal roughness. So these are machines that because there are many factors. But ideal because of the tool angles and radius, we can get exact shape, exact flat roughness. So the idea of it is best possible by the ideal operation can be called as ideal. Okay, and this force is not again naturally not naturally is different. You can get it by something different, but ideal that can be maximum that's sufficient for ideal, and it is the best possible. Okay, so this is and this is making the sides also. So ideal will be correct answer. Best possible machining process can be possible for machining operation with ideal of this. This question in grinding operation, the most important variable affecting the surface finish is. So I think you have answer. In grinding operation, the most important variable affecting the surface finish is. Instead, no, you know the formula. Okay, you must know the formula. What is the formula for that? In grinding, surface finish, grinding. What is the formula for that? You know, if you go through slides, you definitely know. But the actual formula is equal to 2 to 5 T1 max square here and D. So it depends upon chip thickness. If you know the formula, you get the answer. That's it. It's that simple. So in field cross field rotation speed had gone and what repeat chip thickness because you know the formula and you got the answer here, so it's very fast. Because you know the formula and you got the answer. The tool changing cost is. So again you need to have formula with it. So that also. So if you have a formula, you can answer that question pretty fast. Because I told in every section, I told that if you have a formula, you can answer that question very fast. It's like guiding map for you. Okay. What they are asking, the tool changing cost they are asking for you. Okay, so tool changing cost, that is R4. Okay. Let me tell you the formula for that. What is the formula for this? R4 is equal to lambda 1 dot T, so that P into cutting, that is tool changing cost dot pi TL divided by 1000 P F into P into 1 by N divided by K. So this is the formula that we have. Okay. So from that you can get the answer. If you know the formula, you can get answer very fast. That is the concept there. Okay. So you have the formula written there, so you can get the answer. You can have 1 minute. That is, you can have 1 minute. If you don't have, I will solve this. You like the time is there. The formula is given, okay, to you, and you can take the answer directly. Formula is given to you. This is the formula, so you can take the answer directly from you. Okay, so this is just go with the answer right now. You have this formula with you, so right now we go with this answer. So the tool changing cost is directly proportional to labor cost. Yes, labor cost is present here. Okay, labor cost is present here. Okay, so this is correct. Directly proportional to field. No, it is not directly proportional to field. It is inversely proportional to field. So this is wrong. Inversely proportional to diameter. This is also wrong. Because you can see here, directly it is there. It's not a directly proportional. Directly proportional to the two change in time. Okay, this is here. It is correct. Directly proportional to the length of the workpiece. It is here. This is also correct. So what which part is correct? It is one is correct because this is the right answer you can get from this formula. You can directly solve the answer. One is correct. Your four is correct, and your five is correct. So what's the answer here? One, four, and five. B will be the correct answer. So B is your correct answer, and this will be your correct format. Okay. So we go to 22nd question. Machining time is. So you can have time. So you can have the formula directly. I can give the formula. So we can start with formula because you know the formula and right now we can start directly with the answer. So time will be ITL by 1000 B speed. So what will be the correct answer? The machining time will be. So directly proportional to the cutting velocity. If the cutting velocity is down, so crop. Inverse is proportional to the field, correct. Directly proportional to the diameter of the workpiece, correct. Directly proportional to the labor cost, so this labor cost, no. Directly proportional to the length of the workpiece, correct. So this part is correct. You also have formula, you can answer everything. Okay, this is that machining time. Okay, we know this is a machining time. So that is actually L by Fm. This is actually machining time, and this can be counted with this. By how? By putting the formula like you know what is N here. Like VC is equal to pi dm. You know this one. Okay. And you used to put this N. You know this one. Okay. This N to pi d you get this answer, and you can from this you can get this equation, and so you can solve this answer easily. So what do we have? This is correct. We can mention here. This is correct, and this is correct. So three and okay. So answer C will be your option. Okay. So this C will be your option. So in turning operation, the surface finish can be improved by increasing feed per revolution, decreasing feed per revolution, decreasing nose radius or increasing nose radius. So you can have a time. What is it? What you know that is what is it? What is the formula for surface shape in turning? Press F square by eta. This eta is exactly nose radius. So this will be eta. So what we want here, surface finish can be improved. It's a tricky question, you know. If surface finish improved means your H will be less. So what we need to do here actually it will be like eta by F square means 1 by H. So we will increase this will increase your surface finish as per the question. Surface finish will increase means per question. Okay, but this is the question. As per this question 23. So what will happen? It will be by increasing the field radius or decreasing the field. Decreasing the field and increasing the nose radius. Okay, so this will answer this. Okay, this two already got his answer. This 2 and 4. This C will be the answer. 2 and 4. This 4. I told you the answer here because what surface finish you are asking, and this is H max. Which surface roughness? So what surface it is improved. Okay, means we need to less H max. Hence we can get total surface finish. So in a turning operation with a sharp tool, the speed given was 0.4 millimeter per revolution, and The tool with side cutting and end cutting edge angle selected were 10 degree and 20 degree respectively. The surface roughness in millimeters will be. Okay, so we start with our answer. Okay, so what they have given here, what they're asking here, surface roughness in millimeter. Surface roughness is what they're asking. They're asking H. Okay, they're asking H directed. What do you have? You have your F, which is equal to 0.4 millimeter per revolution. You have your this cutting edge angle, means side cutting edge angle, that is gamma S you have is 10 degree, and gamma E you will have this, which is 20 degree. So what is your formula? H is equal to F divided by tan of, this is your gamma S, plus cot of your gamma and cutting. So if you put here, what will your answer? Just to be 0.4 divided by tan of 10 plus cot of 20. Okay, tan of 10 will be cot of 20. Okay, so if you put here, your answer will be 0.13 millimeter. Okay, this will be your answer. So just put there with 13.30 millimeter. So on the same, we have this question, exactly same as same. We have this question. We'll take a minute if you want. It's exactly same. You can say these are the same exact formula. I told you the formula obviously also. So here also what will be the formula? I can write here. Your H is equal to F by tan of your side cutting edge angle plus cot of end cutting edge angle. Your formula. And what do you have here? You have everything here basically. You have point 0.8 here, this 80 and 20 you have. So just put in formulas and you will have the answer. Okay, that's it. I think you will calculate the answer. Your answer will be H equal to 0.8 you have here divided by tan of 50 plus cot of 28. So your answer will be 0.3723 millimeter to be your surface roughness. Because H we are calculating. Surface roughness, not surface finish. Surface roughness are calculating. Okay? 2723 will be the correct answer. So right now we're going to question 26. In turning operation, the field given was 0.4. So we now have field 0.4 millimeter per revolution, and the nose radius of tool is 0.3 millimeter. So what is your nose radius? 0.3 millimeter. So what is the formula do you have? H. Surface roughness in millimeter to calculate. So H will be, you know, x square by eta. I already told you x square by eta. Again I'm talking 8 like this, but eta. Okay, so it will be 0.4 square by 0.3 into 8 is equal to 0.06666 millimeters. This will be the answer. 0.666 millimeters. Okay, the same question we have here. You can take a minute to answer the question. Again, I write the formula for you. It will be h into f square by eta r. So you find you have f square. Okay, you have f square. You have eta. This both the formula you have. Just put it and get the answer. As simple as this. So I hope you calculated the answer. This is exactly the same. 0.5 square into 8 into 0.6. So it will be 0.05208333. This will be your answer. Okay, this is your answer. Okay. Next question. In grinding operation, calculate the surface roughness in millimeter if maximum chip thickness is and the depth is given. So you know the formula from previous. So I told you the formula. So what is your H in case of grinding? 2.25 P square 1, that is maximum thickness divided by D, this is the method. So you have D max and D also. So you do 225 into your D1 max, that is 0.05 square divided by D is 0.8. So your answer will be 0.7031 millimeters. 7031 millimeters. This is the same question, but slightly twisted. I write the formula for you. It's slightly twisted, so you can get more time to solve that. Formula is 2 pi t square 1 max divided by depth of cut. So right now they are asking you depth of cut. A slightly changed formulation, but it's exactly the same, just formula. You need to find out what will do. If you go here, it will go here. That's it. So your d will be equal to 225 e1 square max by h is again equal to, you can solve it with me right now, you can solve it will be 225 0.01 square divided by 0.5. You can tell me your answer, or when you got, I will tell the answer. You calculate the answer here now. You got your answer. 0.045 will be your correct answer. That is mentioned here. Okay, so right now we have some formula change. For we are going to the turning again. We are actually looking cost. Machine cost now. We are looking machine costs now. Okay. So read the problem. For a machining of a 180 millimeter long cylindrical workpiece with a spindle rotation of 120 equal to 0 rpm and speed of 0.12 millimeter per revolution, the overhead per minute was increased by 100. The machining cost of this piece is 0 rupees. So what is the formula for this? That is basically answer. Is equal to Pm into lambda 1, lambda 1, okay, which is we all do. You know the answer in that question. Okay, previous question, you know the answer. That is L by how can I go to find here anything. But here it's directly there. Okay. So you have length, yes we will have length, you have F, and you have yes we have M, and you have lambda, this also cost also. So just put it in equation and you will directly have the answer. So it will be 180 and what's in millimeter. This RPM is in millimeters, means in RPM. Everything is millimeter and RPM is in meter, but your cost per is also in minutes, so that will be compensated there. Okay, so 180 divided by, we need to be careful about these equations and these units every time. Every time we need calculation. That's it. F is 1200 So uh, that is your RPM actually, and F is 0.12, and your is 100. So what is your answer? Just put this. You have F, you have N. Put F here. Put N. N at N, but F N L lambda. Everything is there. Just put four quantities and solve. That's it. There is nothing. There's nothing major involved here. Okay. This 125 will be your answer. Rupees. It is mentioned in rupees, but rupees because your 100 is in rupees, so we are also rupees. Okay. Okay. So this is the same question. Okay. So see the 125 here. Okay. So this is again the same questions for machining of. So you know the formula. I need to calculate the answer exactly. You see. So the formula will be LFN. You must know formula. You have to learn this formula and calculate the answer every time. Okay. So for calculating, I will give you some 2 minutes, 3 minutes if you want. Usually 2 to 3 minutes. This is not 3 minutes question actually, but you can get 3 minutes. So what you have here? You have L. Okay, you know you have L. Yes, you have L. Yes, you have F. Yes, you have F. You have N. Yes, you have N. What you and you have lambda also. So what you get? Cost simple. If you want, and this four you have. So just calculate. So L is equal to. I hope you can put the answer. Is 60. It's, everything is in mm, and your m, that is rotation per minute, can be taken by this minute. Okay. F you have 0.24 into 2400 into your cost 50. So your answer will be somewhat 31.25 rupees. Okay, not for rupees, right? Rupees. Okay, so 31.25 will be your answer. Okay, for a machining operation, it takes 80 seconds to complete the operation. Tool changing time is 100 seconds and the tool life is 30 minutes if the overhead and labor cost are per minute paid for this operation is per minute. Again, see the per minute here. Per minute and is 200, the tool changing cost is. And the RPM is given. No, it is not required here because it is tool changing cost now because there is no RPM involved because we are not taking the grinding here consideration because it's machining operation considering and the grinding is not considering here. So the grinding is different type and tool changing cost were calculated, so there is no machining involved. So there is no RPM involved. So you have to be careful right now. Minute, second, minute, second, minute, second. Okay. So from the slides you can get a formula. I created a formula for you. And you can solve right now. Yeah, here it's is equal to R4 is the standard. Okay, we know from the slide it is standard. So it is Tm by T, which gives the frequency of tool change, divided by T, that is changing cost, into the labor cost. That's it. So do you have TM with you? That is machining cost you have. Yes, you have. It's 80 seconds the machine cost. But again, in second, I told you check seconds RPM, meters, check everything. And tool life you have, it is in minutes, 30 minutes. TCT is time again in seconds, and with labor cost is per minute. So that is the problem. So to convert everything in minutes, it will be easy for you to solve. Converting it in minutes, and it will be easy for you to solve because it is change of no change of minutes are there here. Everything is given to you. So what would I do? So here we just take the answer, that is TM you have 80, but it is divided by 60. Again, do live, which is again a minute, so no to change. Your TSDT is there. It is 10. Wait in seconds, 60 in 200. So just do your calculation. That's it. Once you do the calculation, it will tell you the like do the answer. This kind of problems are there in assignment also, but that is the problem that this is correct hours because second matters. The second matters there. In assignment, it is not mattering. But the second will matter. Okay. So you do this calculation now. Calculator you can use. Okay. This is your answer. Okay. Okay, I think what is a simple calculation. Okay. So 1.418 is your answer. So the same question it is there. Solve it. So I will give you the time. Okay. 5 minutes time you can take if you want. So again a simple question. Here simply solve it. Okay. No formula. Okay. So I will write the formula for you. So R4 is just a convection because it is written there in Latin. Okay. Okay. Do your lambda 1 is your labor cost. So you have everything. Just calculate the answer. Okay, after 3 minutes, I can start solving. It's not for 3 minutes, for 2 minutes, for 1 minute you can solve. It's very simple. I told you the answer previously also, but make sure the second and minute conversion. Okay, so I told you again also to make be cautious about this second and minute. Okay, and these millimeters and meters. So be cautious about this. This cause a problem to you. So this thing mostly cause problem to you. So be efficient with this because it will change everything. Because their answer will change by 1,000 factors and it will be completely out of range. So you can't do anything. So you can calculate correctly what you are. Not it's not it's wrong how you can be calculated correctly. It's wrong to be calculated. You know the formula you go. You just replace wrongly. Yes, like in the gate it's problematic because you study everything, you know the formula, but you placed it wrong. In gate, this kind of problem is there. Like mostly stuff changing units will be there in gate, so you need to be proper with things working with this. It's okay. I think you have sufficient time. Just wait for more time. I think you have sufficient time. We just put the values there. Nothing right now. I told you everything. Or to have TMU required. So it is to life. This is machining actually. Machining time it will take you 120 seconds. That's only. We ready with the seconds and minutes. So review 120 by 60. So 2 minutes actually. Divide by 1 by. This is 1 by T I'm taking. Tool changing is tool life with 230 into your changing time. What is it in 50 seconds? So we'll log in divided by 60 into your lambda 500. So just calculation is only even here. So what is your answer? 1.0. What is it? It will be 1.0896 rupees. So 1.0896 rupees is your answer. Because this is in range, now it should be in range. That's why it is not here rupees or anything. It is in range. It should be proper in this range only. Because rupees you can't write there. It is in like numerical type question. So must be in the range. It must be in the range. Please write a different question now. You can try. You can try. We'll give you some 2 minutes. What they are asking is a question. The feed per tooth in millimeter. So it is a meaning operation. So we need to apply meeting formulas now. The feed velocity that f you can just write the given direct and you can call the answer. So your feed is actually your feed velocity is vf. That's a feed velocity they are asking. See 10 meter. Okay, again see. It is meter minute. See, I told you meter minute you need to be very careful. Okay. Rotation frequency of the milling cutter was 200 rpm. The number of feet per two. Look at this simple formula you have. So you must know the formula. It is very important for your assignments. Okay. So this F is equal to PF into this divided by NZ. So you have this number of tooths specifically. I is RPM, VF is tooth velocity. But again, what is the problem? This meter per minute. So change it properly. And your RPM is in minutes. So this again see this minute we will cancel it because it is opposite to each other. See here. So these things will be checked. Always take into consideration. Okay, this BG and D. So right now we don't need to convert it into minute now because why? This cutter will cancel the 60 euro. But is what I'm actually telling to you is means for this right now what we'll do? We'll multiply this divide by 60 for converting into seconds. But your RPM is in a meter, which is a minute. M this is minute, M is minute here. And you could again multiply by 60 because you have to divide here by 60 and here it will be here it will be 20 here because number of roots are at is the divided part. So what will happen? This 60 will cancel. So what will happen? So you need to take into consideration. But if you want, you can take into consideration. That is what I am telling you. Okay? That is what I am explaining to you. Okay? This can be cancelled out. The same thing I am explaining to you at that point. Okay. So what will remain with you now? It will be 200 into 20. 2000, sorry. And your answer will be simple again because 1000 go, this go, this go. Should be 1 by 4. Simply don't need calculators even. Simply only 1 by 4. So we find. To find. Millimeter. The speed. The speed per tooth here. Millimeter speed per tooth. This millimeter per tooth. Okay, check the unit. Unit is not required. Unit is required here, but not unit right. But unit must right because it is in the region told you. If you got it wrong, if you got in meters, then your answer will be something else. You got centimeters, your answer will be something else. Okay, so that range you need to be see everything. When you're putting something in the range, you check everything. That's the concept. That's that you should work on. That's the concept here. Okay, so we go with next question. Okay, okay, still the same question. You can solve it. I would give you the time. You solve it question. Okay, solve it. You 35. I can go with like 200. I will give you. I will write a formula for rotate one. No, the same formula we have. What is the formula here? F is equal to PF by NZ. So what they ask, feet per tooth. Again the same thing. So same question. You will get this answer. You have VF. Again check meter per minute. So again RPM uh, minute. So I will not use that right now. A number of feet. So it's very simple now. Very simple. 2 to 23 because this is asking in millimeters. So this is not in millimeters. So divided by 10, your n actually put straight first. No, no problem. 100. That's it. The answer will be simple. This this will go. This will go 2 will be remain. So don't use terrible elements. You leave point 0.5 because you know how I cancelled everything. This 3 will go with this one and this 2, and here got 400, so this 2 will be 1 and 2, so 1 by 2 it will be 1 by 2 simply will be 1 instead of 0.5 millimeter per 2. That will be your answer. Okay, it's simple. So that's simple. It is okay. So you got the answer right now. 2.5 is your answer. Right now we're going again with the tool cost concepts. And I told you tool cost per varying asked you means tool cost for operation. So to check the frequency. Simple. Frequency into time is cost, labor cost. It will be your tool cost. You know from the slides, you can use from the slides. It's simple. Calculate it every your time. So I think we have the answer. Okay, so we can solve right now. I think we have the answer. I hope you have the answer. From the slides you can get which is the side directly written what you want and what you actually want. So are fine now. Because it is standard connection. It is there in slideshow. And this week for like I don't know many times right now. This week thing is all right now. That's what to answer the question by yourself. This week. This what many times now. And it is directly here because there is no anything you to apply. It's direct there. It's directly there. Okay. So this parameter to have what is that 20 you have. And it is your TM that is measuring but it is in seconds. You have to be careful. Okay. And it is fine. Okay. That's how the question now answer is about like this. Just use your calculator. That's it out. Like this will be 1 by 3. This 11 by 1 into 11 by 3. Equal 3. We can 3 because we can get by 3 means it will go to 9, 9 and again it will go to 20. So to 20, so you can get the 6, 6, 6, 6. Like 20 means we'll got 80. And if we do the 3 divide this, we can use calculus. But this will be recurring. So it will give you the answer in recurring form. 3.6666. I showed because it is what is the part 11 by 3, so it will be recurring. Okay, so 11 by 3. So this will be the answer. A mile steel workpiece is turned within 130 seconds and tool life for the operation is 2.5 minutes. Tool cost for grinding was 80. The tool cost in rupees for this operation is Just calculate yourself first, and then I will tell you the answer. Okay. Again, I will just write the formula for you. The same formula. Same formula. That's it. And just solve the calculation. That's it. I think you have solved it. Okay. So we know first the time right now. So what do you need? So this you have here. This you have here. And this you have here. Okay, so color list. This, maybe this. So will be 80 into your 130 by 60 into 3.5. So will be 49.52. This will be your answer. Okay. So in milling operation, feed velocity is 2.8 meter per minute. Diameter of wheel is 20 millimeter. Rotational frequency is 500 rpm, and the number of tube per milling cutter was 20. The surface roughness in millimeter. Then you can put here is also if you want. Keep hearing. Go to the slides. It is there in slides. Simply what the things that you have here. You have a feed velocity. So simply you have here is 2.8. So 2.8 simply. But again check what is it. It is millimeter per minute. Okay, so you have to be very careful about it. That's it is in meter per minute. Okay, so you have to be very careful about this again because there's a conversion between a millimeter minute and second. Millimeter per second is actually what we use because it is small. So to go with that convention only, but mostly there's a two change in the units, so we have to be very careful about the change in units. Okay, so to tackle about that change in units. So what you have here, so can be converted into, but does it require to convert? It depends upon the formula, but check RPM is given to you. Yes, RPM is given to you, so mostly you may not require. Simply, mostly you will not require because at 60 it should cancel anyhow. But you can put if you want, you can put. If it is getting cancelled out, it anyhow it will cancel out. But we will double sure. You can put obviously you can put. Mostly go with this millimeter per second settings on this. So here again they are asking for millimeter. If there is no any concept, still go with everything. Keep it in the same unit. Don't change anything. Okay, everything should be in same unit. Right now there is no any concept of cost involved. So that cases that time it required the minute part. But here, at that time we required minute part. Here there is no any cost involved. Just we are recording H. So in that H the minute will be cancelled out by your RPM. But again it will matter. Okay, so things will matter. So you have to be very careful about because the cost will change in that cases here. The surface will be something else. Right now you can see the way surface is changing here. It will be 10 to minus 4. That will be minus 4 millimeters, so it could be some minus 7. So again, not good. We can see in nanometers also. Some 10 nanometers you can have. Yes, about 10 nanometers you can see, but in very high, even in very specific cases, an atomic level, but it is very costly mostly. You have to pay for that, but for that ultra high surface finish, ultra actually. So what we are having to we saw here, we're just changing to keep increasing. So this will be 10 to 3 divided by 60. Okay. What is your diameter for wheel? Yes. Its diameter of wheel is generally in capital D. And the rotation frequency that is RPM, it is 500. The number of pitch that will be your set. So you have VF, D, and Z. And you ask H. So what is the relation between this? You have to find out from the slides. And you can solve the answer here. You have these things, and you can solve the answer here. This because anyhow, and H max is millimeters. So keep everything in millimeter. It is already some part is millimeter. So yes, number of fields are not on the VF field has it. And right now what is the unit of this? Because we converted it right now. Okay. So what will be unit of this? It will be millimeter by second. So to solve the problem, check anything. Go to the slides. What information you can read. So we have to give you some time. Let's have some time. Go through every concept. Mostly go through everything. This is also important for exam also. You know how to get exam answer. Okay, let me tell you. I think I give you the time. So here the answer for this. H is equal to Pf square divided by 4t and square z square. So where should you find this? You know it is milling and finishing. So here you can find this right now. Like this formula you can get in milling operation plus finish surface finish. Milling operation plus surface finish. Here you will got this concept. Okay, so there you will got this answer, and as you have the formula, just put the answer. That's it. I will tell you this answer when you can have time to answer, solve it, and I will tell you after this. So I think we have calculated the answer. So what we have, H is equal to VF means 2.8 into 10 raised to, we don't put like this. What will how will do? 2.8 square into 10 raised to 6. And it will be there cancel also. So into 4 it is constant, into D you have 20, and from into S square it starts. And third you have 20. You see here, I'm not taking 60 anywhere. See, I will write it to here, but I'm not taking. Why? Because this. Because I'm not. Because if I do this even, what would happen? This 60 will get cancelled. So I keep it in. That's all. and you can see both of them are in square because D here only D is in, because you can see the D is in without square, and these both are in square, so this both cancel. Cancel what? Cancel 60. So this you can directly do this if you want. Again, what we'll do, just write here 60 square and write here 60 square, and because this 60 will came here from this, and this 500 by 60 square will came here. What will do? Cancel it again, and okay, so your answer will be h is equal to, see to how small it is in raised to minus 7. Then this will be your answer. This is still very small, very good. So this is very good circle. It is millimeters. Basic millimeters means it will be like 9.8 to raised to minus 7 meters. If you go somewhat less, it will be in nanometers. It will be like 98 micro. Yeah, this is surface area one. You will go micrometer. Okay, this is some millimeter. Okay, so it's the same question for you. Solve. I will give you some time. The formula is same. Just start. I will give you time. Exactly right now. So by complete level, you can be. If 3 minutes I will do, by 4 minutes I will give you and solve the answer. After that 4 minutes I will solve the answer. Let's check we have. Okay, so it is the same thing. Solve it. Okay, start right now solving the answer. So what to do? Your formula is written already. H by Vf square divided by 4d square z square. So you have Vf. So you have Vf which is 4.8. Just write it differently. Anyhow, it is in millimeter or decimeter. 4 is constant, d is something you have, which 10 meter, and you have 800 square into 3 instead of square. So solve it. It's 1 into 10 is to minus 1. So this is satisfaction. It is actually exactly 1 micrometer. 1 micron surface we should get here. See how much finishing will get 1 micron. Again, for some applications, this 1 micrometer is very big, because if you require 1 nanometer finish, it will be 1,000 times bigger. See, 1,000 times bigger means, you see, this will be 1,000 times bigger for this nanometer scale. So this will be your answer, and this is your last question now. Solve by yourself. You will take 5 minutes, so you can take 3 minutes, 4 minutes. You will have solve the question. What is given here? The milestone work is done, so that's not a key. For 150 seconds, and the tool life of operation is 5.5 minutes. The tool cost is rupees. For this operation is rupees 5. And take it like that. Just scratch this. This is last question. I think. You can scratch these things. And what is given for you that? Let's put right. What is given for you? The steel work is done with 150 seconds. Means PMD will give to you. The tool life is due to you. And the operation cost is given to you. Total cost is given to you. That means R5. It's grinding. Yeah, grinding for R5. Is given to you, which is 5 rupees 5. Calculate the formula from see the previous questions or any small question that we have. We satisfy these three conditions. And what we require? Grab this lambda 2 we need to find. So this is the red thing. Okay, so I told you everything. I saw this question. I told you everything here. Okay, solve this question now. Which formula is there? Go through previous slides. It is there in previous slides, so go through slides. Which formula can be applicable here? And what is the basic mechanism behind this? You can see the way you can think about this problem, the way you can solve this problem. What they are asking here actually. Tool cost per grinding for this operation is given to you. So grinding cost is done by someone else. They are not considered. For just you have to find out tool cost is per grinding. This grinding is done by someone else, and someone else will take care of everything, the labor cost and everything, transportation, everything. But you need to find a frequency. That's what you need to find it. How you calculate the frequency? Simply the machining time you have divided by tool level, that will be the frequency, and you multiply it by what? The cost. Means your lambda 2. This is simple ideology. If you go into the slides correctly, it's very simple, and that would be the grinding cost. This is the formula. So it's very simple. I told you previously also that this would be your formula. Once you have this formula, this basic concept you will have, you will create a formula then itself, and you can find the answer then itself. So this is basically to understand wow. This is the way that you need to understand the reason behind this thing. That why this formula is like what is this? This is actually the way you can talk in science. Mathematics is a language of science. Simply the way how you can talk by using mathematics, you can talk about this science. So this is science. This is mathematics that we got from this science. That you have to change this tool. So you need to read the frequency and how we can get the frequency that is right. Machine time by tool life, because when the tool life is got over, you can machine it. So to change it, so again change you need to change it to grinding, and that much time to grind. For how much time? What is the cost for that grinding? Will be the total cost for grinding. That's simple it is. Just calculate the frequency. How you can calculate the frequency? I told you the formula. So you have everything. You have TM, you have T, you have R here. Actually, alpha you have, and you have lambda. So everything you have here. So what you do? Just calculate lambda. That's it. And how you can calculate lambda? It's again very simple. I just told you. But that is your answer 11. Your answer 11. Okay? So alpha is equal to so what it actually mean here? Change it color. So it will be 5 rupees. Actually, 500. 5 rupees equal to average 2 into 150. I told you previous slides that what is 150. Okay, because this your seconds. See again seconds. and your past is minutes, mostly in 0 minutes. So divide by 60 the total here. To check, I told you check these things. Minute and millimeter and meter. What I told you. Millimeter and meter to check this or vice versa, like this side outside, and your second and your minute. Okay, and on this vice versa, you have to check very carefully. Okay, we have to multiply, divide, do proper mathematics here. So here I have to divide by 60. Okay, into your what left for you? Just this, but not this. This is your, if you got this is you got, and simplify. This you got, and this will have into submit there, which is 5.5, and your answer will be lambda 2 will be 5 into this, will go there 65 5.5 divided by 150, so your answer will be 11 here. Okay, so your answer will be 11 here, and this is your answer. Okay, so 11 rupees is your answer here. So this is your last slide. Okay, this is basically, this is how you can tackle the problem. We are here to learn the problem, how to solve the problem. Okay, so your assignment submission date will be this Wednesday again. So solve your sum into Wednesday. Okay, so I told you can go through that assignment. This is your problem set, and you can go through the assignment. So we get definitely get out of it. But there is one problem there with right divide by 10 concept. I told you that I give the red mark here. So that is problematic. You can ask doubt. I encourage you to ask that, because it is wrong. So you must ask that. You will get after you get a solution answer. So you ask that doubt, and so here we end our doctoring session. So thank you for your attention, and here you are ending our doctoring session, and do submit your assignments. Okay. So submit your assignments, and here we are